Okay, so again, internal resistance is similar to air resistance. We ignore it unless it tells us to consider it. Does that make sense? So
when it says the voltage across the battery, does it mean the battery's EMF or like
the EMF.
the EMF?
Oh. Nope. We'll say the terminal. That's the. Tell your neighbor.
Also say that the resistance, which is the one that is which one is what is EMF? What is the actual resistance?
Okay. So EMF is. Okay, that's a good question. Okay, for clarification's sake, EMF is the ideal voltage on a battery. The terminal voltage is what actually is after you hook it up and there's circuits and there's current and internal resistance. Does that make sense? So EMF is your ideal and your terminal is your actual. Correct answer is C. Everybody go to C? Okay. We have a short circuit. Current goes. Good. Okay. Technically, there will probably be a little bit eking through here, but not enough to make a substantial difference. Be like 3.01 or something. I don't know. Technically. Have a conversation.
Numbers on my side. No, you have numbers confused with hits of the stuff that don't lie. The answer is D. I'm sad that I got this. How do you know? Everybody on I just don't like Shakira.
Correct answer is. Correct answer is A. 9 volts, 9 volts, 9 volts, 9 volts, 9 volts, 9 volts, 9 volts. 9 volts, 9 volts, 9 volts, 9 volts, 9 volts, 9 volts, 9 volts. Good? Oh, buddy.
What the heck? Oh my god, no way.
Wow.
No, just think about this.
Okay.
No, it's still
There.
no,
Yeah.
it's still the voltage.
Because the loops.
So we've had to rewrite Pago 5. Actually, no,
I just
way
there's 4 loops. So now
says that you will get the voltage at both ends.
there's 5 loops.
It doesn't do
Well,
it.
how is there 5?
Okay, so this is the one that
It's
goes like
purely
this.
decorative.
That's the one that goes.
Correct answer is still A. Yes? Okay. I think some of you are anticipating what the next question is. So we did not change the circuit. I just changed the electric potential at that location. Thumbs up when you have a guess. Have a conversation.
I was thinking oh, I'm such a freaking idiot. Don't say that about 3 times 3 is 9. 9 makes it 3. Or 9. What? Shut up, Joe. Don't tell me what I can't.
Correct answer is? Correct answer is E. 0 volts, 0 volts, 0 volts, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0 volts. Way. Here we go, here we go. Which way is it going through this resistor?
That's the fastest way.
Thumbs up when you have a guess. Converse.
If there's no voltage drop across the resistor, you can't be doing current.
And also because it's going to be what's your
What in this ideal scenario?
So it only goes left or right. Because if you no, that's true.
when I hear this black magic,
I'm gonna go with my gut on this.
Oh,
Because that always got me where I was going.
Correct answer is to the right. To the right. Why? Because you have 9 volts here and 0 volts here. That's downhill. You okay with that? Last question on this circuit. Nothing. Nothing changed. Same circuit. I'm just asking a different question.
Because I mean, no matter which way it chooses to go, there's only one real. Yeah. But aren't all those three ohms resistors in parallel?
Rule of thumb.
So you have to wait.
So
So we have to.
They're supposed to be 9 volts with 3 ohms. It's 3 amps, and so when they come
I mean,
together, they're
I'm
gonna
just
add.
telling you the logic that every single one of them is going from 9 volts to 0 volts over 3 ohm resistor.
What?
And every single one of them is 3 amps, and they're all going in the same direction.
Correct answer is
I guess.
okay. Here we go. Ready? So 9 volts, 9 volts, 9 volts, 9 volts, 9 volts, 9 volts, 9 volts. Yes. 0, 0, 0, 0, 0. 0 volts. 0 volts. So across each resistor is a 9 volt drop. So each resistor has 3 amps going through it. When they come back together, you get 9 amps total. This is actually a parallel circuit wired in a really weird way. Does not matter. Because, okay, so this wire here so this has 3 amps, this has 3 amps, this has 6 amps because of junction rule. Okay, this has 3 amps, so when this hits, this now has 9 amps. Yeah. Crazy. So, like 9 amps would be here, and then here, 3 amps goes this way, 6 amps goes this way. And when it splits, whoop, whoop. Good. Let's kick it up a notch. Okay. This means you jump over the wire. You don't go. There's not a junction. If that makes sense.
Go over 3 ohms.
Yeah, actually, yeah, that's
It doesn't pass by register.
Number. 9 volts above that.
It doesn't pass by register. Yes, it does. Did you take the most direct route? Yeah. How do you get there? The arch meter goes over that. The negative battery. The positive terminal. So it has to be 9. I thought you said it had to be 0. Oh, it's a 9 after 9.
What are you going?
Have a conversation.
Which means that.
What's your answer?
I'm gonna say.
That resistor
There's a drawing.
across.
You're saying it's 0.
Those resistors is not that resistor.
Are you serious?
Wait, what did you say?
I would think that.
Yeah, it's right in the middle one.
So it'd be 0 across all of them.
Because
Oh, I'm being stupid.
Yeah.
This guy's
So what's the answer?
9 volts.
Right.
There's
There's no resistors between it with that. You got there.
What do you mean the bottom of it? So like the plus.
Correct answer is. Correct answer is yes. A. Yes. You have a path here that's inhibited Okay, so no voltage drops, assuming no resistance in the wires.
Wait, which one you say? Wait, the one the very.
We wouldn't go over the right.
It will.
It would never.
The
Yeah.
bags are both the top and bottom of the right one are 9 volts, so it would never.
Oh, so go through the bottom.
So it's going like.
So the bottom.
Yeah, it'll just. This is.
So the left and bottom of both sides. It'll still go through the middle. Why would it not go through?
Okay, correct answer is
How do they operate? There's no resistance. Oh, yeah, okay, so it'll go through the middle. It'll go through left, right, bottom, and they're all sides, and all sides.
I'm gonna go up here and point at what I mean. I'm going up there and pointing at what I mean.
As a team.
1, 2, 3. Okay.
I have one more meal. It just, we had a fluke of it. Would your family eat canned beef and broccoli stir fried over? Would you or somebody else come down and just pick up a bag? It has all these, it's not made, but it has a pound of ground beef, it has the fresh broccoli, it has everything in it to make it. You want
today.
that today? You want to? Or you have to send somebody else with it?
Yeah, I can
Do
do
you have a
that.
refrigerator?
Yeah.
You don't have to take it if you don't want. Would your family eat this?
Oh yeah,
Okay.
yeah.
I have 9 study hall.
Okay,
Are you-
me too. Yeah, I've got period 9 prep, so that'll work.
Okay, so I'll send somebody else with it. I'll get one of my.
Oh, you sure? Oh, I
Well,
mean,
if you have a refrigerator. Do
Yeah.
you have a refrigerator?
Yep.
Yeah, one way or the other. I'll send.
Okay.
Send somebody up. Are you gonna be in here? No. Okay, send. Okay.
thanks.
Oh, no. You're blessing me.
Okay, correct answer is A, 9 volts. Still connected, yeah? Right here, 9 volts, 9 volts, 9 volt, 9 volt.
Look at us.
We just did this one.
Right on the lab.
Just like sitting here being lucky and doing myself.
Technically.
Wait, that's not possible.
I know it is.
Who's saying the best? So instead of 4,
Correct answer is. Correct answer is C. No currents, none. You have 9 volts here, 9 volts here. There's no motivation for the electrons to go anywhere. Like, why would I want to go over there? It's just as crowded. That's true. They're more impulsive. They're just driven. They don't have choices. They're just driven by nature. Okay.
Yeah. We should have the links.
Undoes us.
Don't make me.
Think about it like that.
That's not it. That's not it. That's not it.
That is true.
He's a real god. He's an e-god. He's a god.
Correct answer is 9 amps yet again. This is another weird way to put parallel. Here's an independent path to home. Here's an independent path to home. Here's another independent path to home. Good?
Oh wait, that's a great idea. What if we just listed this here baseball? That's baseball. What's your electric computer? Okay. What is this?
Tell your neighbor.
No, he is.
No, he's engaged.
Wait, no.
Correct answer is B. Okay. These are both in series. These are in parallel because they're identical. The voltage drop, let's say this is 10 volts, has to be 5 volts, 5 volts drop. These are identical, 5 volt, 5 volt. Good?
Ammeters can't read. Technically speaking, ammeters not equal. That's what I'm saying. So it'd be 0. Ammeters can't read.
Don't have eyes. You read.
Wait, isn't it still 0?
Correct answer is C. 0. You have 5 volts and 5 volts, no current. Good with that? Okay. So for kicks and giggles, let's say we made this 5 ohms. Then we made that 15 ohms. Let's say we made this. Say we made that 20 volts. Okay. In this branch, forget the. Okay. So in this branch, there'd be a total resistance of 20 ohms. So there'd be a current going through here of 1 amp. Good with that? If I had 50 ohms and 150 ohms, there would be 0.1 amps flowing through this branch. Yes? Okay. If I connected this with an ammeter. We'll just say which way is the current going? Down, up, or zero?
Just we should make stir frying here. We should have a stir fry party in Mr. Smiles. Doesn't that sound fun, Mr. Smiles?
It's fun. That one.
We could use like induction stoves to warm up induction. It's science.
What do you say? Up, down, or nothing? Correct answer is nothing. It's about the voltage. Okay. Here, we've got, this would be 20 volts. This would be 15 volts. Yes? You have 1 amp going through here, so you have a 5-volt drop. Here, 20 volts, you have a 5-volt drop across here, so there'd be 15 volts here, 0 volts. Good with that? All right. This is just for kicks and giggles, just so you can be exposed to this. This is not going to be on the AP test. This is, okay, so if you run into an old school resistor, they only have 3 colored bands, and then this is like your tolerance. Okay, that's just how expensive it is. So what you do, the first one is your first digit. So this would be brown. So you're looking up brown 1. Okay, so we got 1. And then your second band is your second digit, and that is black. Up 0. So I got 1 0. And then your last band, this is true, consistent through all these, your last band is your multiplier. So you go, so it's 1 0 times orange 1,000. So 10 times 1,000, you get 10,000 ohm resistor. Okay, you don't need to memorize this. You just look this up. I'm just showing you how to read these. This is not okay. So here, yellow 4. Remember that 4. Purple 7. 4 7. This is a third digit. 475. 475 times red times 100. Okay, so 47,500 ohms. Okay, get that? So see if you can, so we've got red, purple, blue, black. Oh, that's lame. Yes, thank you. Okay, good with that? So, just wanted you to be exposed to that. We'll call that good for today. You got your lab. To finish, if you have questions on your expert TA, if it's Kirchhoff's loop rule, I'm just going to blame it on your math. You dropped a negative or positive or substitute somewhere. That's my guess. If you have a conceptual setup problem, I will totally help you with that. The rest of the time is yours. Tomorrow, we start on RC circuits. RC, resistor capacitor.